Assalamualaikum, my name is Muhamad Syazwan, and today I will present to you about Power Cloud Security Anomaly Detection using Isolation Forest and XGBOOST. Project background. Cloud computing has become essential to modern IT infrastructure, but storing sensitive data and critical applications in cloud introduce significant security challenges. Traditional rule-based and signature-based IDS cannot detect zero-day attack, and they also suffer from high false positive rates. A hybrid approach combining Isolation Forest and XGBOOST bridge this gap by improving detection precision while reducing false alarm rate. Problem statement. The first one is existing cloud security system rely on outdated dataset, which may generate excessive false positive that overwhelm security analysts. Next is a supervised model fails to detect zero-day attack, while unsupervised model lack the ability to suppress false positive. The project objective. The first one is to design a hybrid machine learning based anomaly detection model for cloud security. Next is to implement the hybrid model for anomaly detection and for false positive reduction. Next is to test the model using the security-centric metrics. Scope of the study. The system is built using the NSL-KDD dataset. The system operates in offline batch processing mode and does not support real-time packet level detection. Significance of study. The hybrid system improves cloud security by detecting zero-day attack using Isolation Forest while reducing false positive using XGBOOST. For performance is evaluated using precision, recall, F1 score, and false positive rate to ensure the system meets practical cloud security requirement. So this is the similar works. For example, Lafmari and Anas El Afa, they use hybrid machine learning model by combining Isolation Forest and XGBOOST and receive accuracy of 99%. Methodology. In this project, I use 4 stage of interactive waterfall, which is analysis, design, implementation, and testing. In this project, we utilize an SL-KDD dataset, which is contains of 125,000 training records, 22,000 test record, 41 network traffic features, plus 1 label feature. From the network traffic feature, we categorize it from 5 traffic, which is normal, denial of service, prop, remote to control, and user to root. So this is the system flowchart. The system started when the user access to the web application and see different 3 pages. The first page is benchmark overview, which is showing the overall performance by all 3 models that collected from the safe model folder. Next is dataset detection page, which is allow the user to do the isolation in real time, which is first one is when the user upload the different dataset, and the dataset will pass to the system and go through the data pre-processing. After the data pre-processing, the clean dataset will go to the feature extraction, which is it will go through the isolation forest training and XGBOOST training that collect from the safe model in CSV storage to extract the features like isolation forest score and augmented matrix corrections. Then the augmented dataset will go through the hybrid machine learning model, and after that it will perform the score and evaluations, and it will serve to the API server and display in the hybrid cascade dashboard. This is the result. The hybrid cascade significantly outperform both standalone baseline through dynamic contamination tuning, anomaly score augmentation, and threshold optimization. The false positive rate dropped from 22% to only 2.82%. So this is the bar chart for each performance metrics like accuracy, precision, recall, F1 score, FPR, and ROC AUC. So for the system demonstration, I will show you the benchmark overview page first. In this page, it will show you all 3 model performance metrics, including this is cascade model hybrid machine learning performance metrics. This is the dataset level distribution. This is the confusion matrix for all 3 models, and this is the full metric comparison. So this is dataset detection page. This page will allow the user to isolate the dataset that fulfill the requirement in real time. For example, I pick this. The system will process the dataset, and the new dataset will go through the process again, and it will show you the result, including the configuration matrix, and you can see the details of each data. So lastly, for the conclusion, this project successfully designed, implement and evaluate a hybrid isolation forest and XGBOOST cascade pipeline for cloud security anomaly detection, achieving all three project objectives. The hybrid cascade addressed two major limitations of existing IDS: inability to detect zero-day attack and high false positive rate, reducing FPR from 22% to 2% only. Dynamic contamination, tuning, anomaly score augmentation, and threshold optimization enable the hybrid model to significantly outperform both standalone baseline, which result accessible through an interactive web dashboard. Limitation: dataset dependency. The system was tested on NSLKDD, which may not fully represent real-world cloud traffic diversity, limiting model generalization to other environments. Offline processing only. The system operates in offline batch processing mode only and has not been deployed or evaluated in real cloud infrastructure environment or under high volume concurrent traffic. For recommendation, evaluation on additional dataset. Future work should evaluate the system on more recent datasets such as CIC-IDS 2017 or CIC-IDS 2018 to better assess generalization across different network traffic profile. Future work should consider deploying the system using Docker on real cloud infrastructure such as AWS or Azure to validate performance and scalability under realistic production conditions. That's all for me. Thank you.